Question 1. Patrick is practicing his skateboard skills. On each day he has 30 attempts at performing a difficult trick. Each time he attempts the trick, there is a probability of 0.2 that he will fall off his skateboard. Assume that the number of times he falls off on any given day may be modelled by binomial distribution. So we know it's a binomial distribution. It meets all 4 criteria that we need. Here we have 30 attempts, so we know that n is going to be 30, and we've got a probability of 0.2. So we know it's going to fit this model where n is 30 and the probability is 0.2. The first question says that find the probability that on a particular day he falls off exactly 10 times. So this means we need to find the probability that x equals 10. So on my calculator, I just go menu, 7, binomial PD, and then just variable. I put in x is 10, n is 30, and the probability is 0.2. When I do that, I get to 3 significant figures, 0.0355. Make sure you go to at least 3 significant figures when you write your answer. So question 1 done, just 1 mark, not too much to do there. Part B, find the probability that on a particular day he falls off falls off 5 or more times. But what this means is we've got so on. We're looking for 5, 6, 7, 8, 9, 10, etc. all the way up to 30. Now obviously we're not going to work out the probability of 5, probability of 6. What we're going to do instead is notice that the probability of 5 or more is just 1 minus the probability of 4 or less. Just be careful there, it's 5 or more times, so we need to include the 5. So I definitely don't want to take off the 5 here. So on my calculator, go menu, go 7, and then we go binomial CD, and then variable, and then we want to put x as 4 in this time. N and P is still the same. And we get a probability of 0.255 to 3 significant figures. Now that's the probability of 4 or less. I don't want that, so I'm going to take that away from the 1. And then I get my final answer there of 0.745. Now part C was probably the bit that had the most kind of number of correct answers out of this question. So this now says Patrick has 30 attempts to perform the trick on each of the 5 consecutive days. Calculate the probability that he will fall off his skateboard at least 5 times on each of the 5 days. Now notice that on each day, from the first part of the question, he has 30 attempts. So it's still the same, he's still doing the same number of attempts in a day. Now in part B, we just worked out the probability he falls off 5 or more times is 0.745. Okay, so this is what we got from part B. Okay, so and just read the question carefully. It says calculate the probability he will fall off his skateboard at least 5 times. So we know that probability on each of the 5 days. Essentially, this is binomial distribution again, where we've got n now as 5 and we've got a probability of 0.745. But you don't really need to kind of do it with your calculator for binomial. All you simply need to do here is realise that you're looking at this event happening 5 times, okay, for every day. So all we simply need to do here is just do 0.745 and raise it to the power of 5. And when we do that to 3 significant figures, we get 0.229. So you can just think about that. If you call, I guess, the event that you fall off 5 times, which kind of sounds weird, a success, then you're looking at that happening every single time for those 5 days. So you just need to do 0.75 times 0.745, etc. Sorry about that. And then we'll get our answer as 0.229. Finally, the last question. This was generally answered very well. Explain why it may be unrealistic to use the same value 0.2 for the probability of falling off for all 5 days. And all you need to do is give some valid reason that he will improve most likely over those 5 days, so the probability that it falls off goes down. And also maybe mentioning some external factors. Some people mentioned weather may come into play. That's absolutely fine. Anything that is going to change that probability.